Welcome back to Grade 7 Math. This is lesson number 5.4, Apply Fractions, Decimals, and Percents. In today's lesson, we are going to put all of the skills we learned in our last 3 lessons together. The following problems will require us to convert fractions to decimals and percents, or vice versa. Example number 1. Hal is selling donuts for a fundraiser. 3 out of every 5 people he asked bought a donut. Show this result as a fraction, a decimal, and a percent. So let me just get my pen ready. Okay, and it's important to look for key information in this word problem. And that key information is 3 out of 5. That information there gives us our fraction, which is 3 over 5. Now, if we want to turn this into a decimal, there's a couple of ways. One way is to use division, or we could actually make this out of a fraction out of 100. And we can do that by multiplying both the numerator and the denominator by 20, meaning that we would end up with a fraction of 60 over 100. Okay, so that means that 3 over 5 as a decimal is equal 0.6. Okay, keeping in mind I don't need to keep any zeros after the 6. Okay, then as a percent, just going with our equivalent fraction here, we see that 0.6 equals 60%. And we can actually check our answer box at the bottom. And look at that. There we go. Okay, example number 2. Clark, Bruce, and Diana are shooting hoops. Clark and Bruce get 25 throws. Diana gets 20 throws. Clark gets 12 baskets. Bruce gets 19 nets. And Diana gets 17 nets. Show each player's record as a decimal and a percent. Which player was the best at shooting hoops? So first off, we need to start with our fractions for each of our players. So Clark got 12 baskets and 25 throws. Okay, Bruce got 19 out of 25. Diana got 17 out of 20. So now for each of these, you notice all of these fractions can easily be turned into fractions of 100, which is really going to help us here when we want to make our decimals and our percents. Okay, so of course a fraction of 25 can be turned into a fraction of 100 if we multiply by 4. So 12 times 4 is 48. Okay, that means that our score as a decimal was 0.48, or 48%. Okay, Bruce, if we multiply by 4 on top, the bottom, we're going to get 76 out of 100. So Bruce's percentage is going to be 0.76, which equals 76%. For Diana, if we multiply by 5 for both numerator and denominator, Diana actually ends up with a score of 0.85, which equals 85%. So let's check the answer box. And we see that Diana was the best at shooting hoops because she had the highest percentage. Okay, here's example number 3. In the month of January, TTC buses were on time 59% of the time. What fraction of the time were the buses not on time? So we see that the buses were on time 59%. And remembering that percent is always out of 100. So why don't we do this? Why don't we say 100 minus 59 equals 41. Okay, that means 41% equals 41 out of 100. And we'll just check our answer box. Look at that. I wrote 41%, which is 41 out of 100. Okay, example number 4. Barry got 35 out of 45 on his gym test. He needs to get 80% to be on the honor roll. Is his test mark high enough to get him on the honor roll? Well, he got 35 out of 45. So let's make a fraction. As we learned previously, to change a fraction into a percent, a fraction which cannot easily be turned into an equivalent fraction of 100, We can use a calculator to guide us, but of course we always need to show what work we are doing on the calculator. So we have to do 35 divided by 45 times 100. So I'll just punch this in on a calculator. And he was so close. Barry ended up getting 77.7 repeated percent. So just reveal the answer. No, he did not get the 80% needed to get him onto the honor roll. Okay, so here's a challenge for you to try tonight, and then we'll take it up in class tomorrow. A community park has a swimming pool. Calculate the percent of the area taken up by the pool. And I'll give you a hint. Before we can write a fraction and then change it into a percent, I think we need to start off by calculating the area of the pool itself. So the dimensions are 40 meters by 25 meters. But then we also need to calculate the area of the entire park, and those dimensions are 60 meters by 60 meters. And no, folks, this diagram is not drawn to scale. Okay, but again, there's your hint. Find the area of the swimming pool first, then find the area of the entire community park. So pause the video and take a couple of minutes to try out this problem, and then we'll see how we did in tomorrow's class. Okay, so after we take up that challenge problem, you are going to get some time to solve a variety of word problems that test your ability to work with fractions, decimals, and percents. But until tomorrow's class, this concludes today's video.